Okay, let's get into it. Lab report one. In this lab, I observed the motion of some object marker um, over time where its speed and direction stayed constant. There were two main parts to today's lab, the experiment and my model. And the physics principles in this lab that I covered include position and velocity over time and the analysis of how they interact. All right, as for the experiment, I set up a system in which I would push a marker next to a ruler and analyze the marker's motion using tracker. So you can see that here, the marker was placed about here, well, it's rolled across here, and there is the meter stick in the background for reference. Okay, and then I used the app tracker to um, analyze the movement of the marker. There were a couple of things I had to do to set this up. So first of all, I had to specify the video length. I had to cut the video length such that the marker wasn't being accelerated. Right, so like where the marker was about here, is being pushed. And then I also had to add in a coordinate plane, which is this purple bar here, and this blue bar here. What these did is these gave the reference point of basically what it was looking at, and how to perceive the depth and the length of the experiment. And so then once that was done, I had to actually extract the data that I wanted. And so to do this, I went frame by frame and selected the marker's center of mass at each frame. Um, and over time, this got me a few data points, which are right here. These are my data points on the left, and using tracker, I was able to get my marker or my object move along the x-axis, or that purple bar you see here, over time. From this data, I could solve for the average velocity of my marker by solving for its initial velocity and its final velocity. So the initial velocity I solved by using these two data points here, and that got me my change in x value or change in position over change in time, which eventually for my initial velocity and my final velocity, changed using these two data points, I got zero point 0.2 meters per second. I think that my initial and final velocity are the same because of how my experiment was set up. Both my marker and the table I used are pretty smooth surfaces, so friction was pretty minimal, so that kind of makes sense that my initial and final velocity were the same. All right. As for my model, the code for my model is on the left here. Uh, and so I used the um, starter code, but I just adjusted a few things to make it more accurately represent what my experiment was. So I adjusted the mass of my marker, and I adjusted the um, delta t, so change in time, to reflect my frame rate. I adjusted the vector or velocity vector, which remained constant, and the um, how delta t changed, velocity changed with respect to delta t. All right. As for my results, the graph for my position over time is on the left, and so is my graph for velocity over time. Um, the results for my model and my experiment are different. And this leads me to believe that there was some kind of issue with how my experiment took place. I think one of the major issues with my experiment was the camera. I should have worked harder to make sure that the camera stayed still for the complete duration of the experiment. And I think that it moved a little bit, and so some of my values were skewed. That being said, however, the end position I got in both data sets were pretty similar. Like my experiment and model were both really similar in length right here. And so yeah, I think the model and experiment accurately represent each other. And I appreciate you for watching. Thank you.